Great. So the session is now fully set up, and I hope that for those of us who are requesting to record the session, please feel free and know that the session recording shall be provided for you to be able to access even after this, so you don't have to request the recording. I want to welcome you to this 3 days sprint in Revit modeling. This program is designed to, it's a free program that is going to be running for 3 days. So it's starting today, being Wednesday. We're going to have it tomorrow on Thursday, that is on Labor's Day. And then after that, we are going to close it on Friday evening. So all sessions are going to start at the same time. Please note that also the email, the link to access this is just the same that you have used today. So you don't have to re-register. You don't have to ask for another email or another registration link. But we are also going to send a reminder for you tomorrow via email, and we're also going to send one on that very Friday, on Saturday as well, on Friday rather. So what I want us to understand is this session is meant to equip you with skills, to be able to model, to be able to detail, to be able to do your documentation. I hope that you're going to make good use of it. I have been seeing thousands of requests, people asking for softwares. We genuinely do not have the capacity to offer the softwares to all of you, and we hope that you understand. 150, and everyone was texting me requesting for the software. We cannot be able to do that. I can see someone is also already activated the whiteboard. I don't know what you intend to do. I can see Natasha. I can see other people have already activated the whiteboard here and they are drawing. So please, I would like us to make sure that we do not want to do this. I can see Protask again is already doing these. So kindly, what I would request is during this session, let us observe online meeting etiquette. Let us not disrupt it for no apparent reason. Let's just follow through. Let us listen. Let us take notes. And of course, if you have any question that you would like to ask, of course, we are going to respond to that. So this session is going to be very immersive. I hope that you're ready. I hope that you're ready and willing to be guided and willing to learn. So please, I have a small thing that I wanted to share with you. As part of these Revit trainings, we have been doing a lot of trainings for engineers across Africa and of course in the whole world. We offer many trainings, and one of them is, of course, Revit modeling. So and training, Revit structure training. If this is your first time and you would like to probably, to undergo a complete course training, so please feel free to undergo that, or rather to enroll with us. This is a paid program, and these are some of the recommendations that we are getting. Engineers are able to get new expertise and skills. This is Emmanuel Gozar. He's a Ghanaian, but he's currently in the US. We have Job, who have been very excellent in the current training module. And we hope that you would like also to get to learn these very, very specific skills. We have seen people improve and learn through this program. And I want to tell you something. We are moving in the era where every project that is going to be undertaken around the world will require engineers who have knowledge in BIM workflows. You cannot excuse yourself. The whole engineering industry is undergoing a revolution. And this revolution is about designing, working, modeling, collaborating, using BIM workflows. And at the forefront of this is Revit. It's a very, very powerful BIM tool. And I think you need to learn it. You need really to learn it, because at any point you must be able to know it. Otherwise, you will become extinct. It's just like the same people who in the 90s and in the 2010s, there in the 2000 eras, they were being asked to adopt computers. They were asked to adopt new ways of designing. For those who moved in that wave, with that wave, they are currently reaping great fruits. For those who did not follow suit, I think today they are regretting and they are wondering, why didn't I learn? So now BIM is currently being adopted slowly by slowly in Africa. Why would you not want to be at the forefront of these tools? Why would you not want to learn them? So we are offering these free trainings for you to be able to learn, for you to be able to grow. And this is exactly kind of a roadmap that we're gonna be having in the next couple of months at Ronsap. So today and for the next 3 days, we're going to have the Revit structure sprint. And in this sprint, of course, we're gonna be taking you through modeling, detailing, and documentation of this structure. Tomorrow, of course, is International Labour's Day, and we will be celebrating your creativity. We'll be celebrating your input and the things that you get to do. And then over and beyond that, next week on 7th of May, we're going to be having the FIDIC contracts, fundamentals of FIDIC contracts, and we have a FIDIC certified contracts manager who will be speaking to us. This program is free, but in between here, that is on 5th next week on Monday, we're going to be starting now the official Revit training for those who have already subscribed to the program. On Monday, the second cohort will be starting, and I hope that you could consider to be part of that. And we'll be sharing the registration link. You can make your payment and we proceed. The last cohort has been excellent, and this is the second cohort, and we would like you to join this one. You don't have to worry. We're going to send you the details for you. And then after that, we're going to be having the FIDIC contracts webinar again, because as you do and as you execute works on site as an engineer, there is a contract, there is a framework that guides these construction works. So it is important for you as an engineer to have an understanding of these contracts. There are different types of contracts that govern construction works, and this expert will be taking us through each one of them. He has been in the industry for the last 9 years or so, and therefore he has experience and expertise to guide you through that. Over and above that, there are a lot of people who have been asking about intersection design program, and the intersection program is going to start on 14th of May 2025. Back again, we're going to be having in June the Civil 3D Campus Bootcamp. This is specifically designed for university students to be able to expose them to the tools that we use in the real workplace. So I am welcoming you one more time to these amazing programs, and I hope that you get to find time, and I hope that you're going to make good use of them. Please, we go through we do a lot of things to make these programs accessible for you and for free, and these events. And we hope that you make good use of them. And our prayer is that the little skills that you get here, the simple knowledge that you get here is going to help you make your career better, so that you can be able to grow and become better and better and better. So please, as you go through this, I hope that you're going to make the best of it. And I'm looking forward to seeing you succeed. This gives us a lot of joy to see you succeed and to use these workflows to make an impact and also add value in your respective places. We will also be offering some discount for people who will be very consistent in this one. So please, I don't know who, but I know the person who will be selecting those specific people. So, ladies and gentlemen, allow me to introduce the speaker and of course the instructor for the first day of this Revit sprint, and he is one and only Gatimu Waithaka. Gatimu Waithaka is a staff at Ronsab. He is, of course, in charge of the structures design department, and he has been also the lead instructor in the last cohort that has been very excellent. They were working on a 5-story building from scratch to end, and we are very, I think you've seen the output, and he will be probably showcasing some, and he will be interacting with some of his students and trainees who are already in this program. He will be guiding you. He is very soft spoken. He will be guiding you slowly and with a lot of humility and kindness. And I hope that you're going to learn from him. So, ladies and gentlemen, Gatimu, please, if you are in a position to take over, please let me know so that I can give the mic to you. Please let me know. Are you ready? Are you set?
Hello, engineer. I am set to start. I can take
All
over.
right. Thank you very much. Take over and take care of your good people. Thank you very much.
So thank you for the warm welcome, and good evening, everyone. My name is Gatiumo Ithaka. I am a civil engineer from Kenya, and I'm happy and honored to have you here with us as we go through the Revit for structure sprint. So before I get started, I have a short presentation to guide you through what we are going to do today. We are not going to be doing a lot of theory. We promised you it's going to be a sprint, it's going to be technical, and so we'll get directly into that. But before we get into that, it's important for us to know what we are dealing with and also know what the journey looks like ahead. So allow me to share my screen. And if you can see my screen, please type a one. So if you can see my screen, please type a one. Please type a one. Let me know. Super. So let's continue. I will go directly to presenting. All right. So this is our Revit for Structure sprint. But before we get to the sprint, let's introduce what Revit is. So Revit is a building information software by Autodesk. It allows us, the engineers, the architects, the MEP team, and other designers to create 3D models for structural, architectural, and mechanical and plumbing systems. So as we talk about BIM, it's important to notice that BIM is a process. It begins with the creation of an intelligent 3D model. And by intelligent, we are referring to data that is stored in the model. So these models contain a lot of data in terms of the materials used, the quantities, the volumes, and you could also schedule them. So they are really intelligent, and they're also really parametric. So it allows us to document, manage, and ensure coordination during the entire cycle of a project. So by the entire life cycle, we are referring to the planning stage, the designing stage, the building, operate, and maintenance. So in the age that we are in, the consultants do not just part with the client after you have finished your design or after you have handled over your project, right? So we live in an age where things happen. You might want to renovate a certain structure, and that information needs to be stored. So the BIM models you'll be creating will also be used during the renovation phase, which you would say is in the maintenance phase. All right, so I will go on. So the role of Revit in BIM. So Revit allows us to work in the same environment. It allows the architects to to model the architectural model in the same work environment that the structural engineers and the mechanical, electrical, and plumbing team will be working in. So even the
You can stop
contractors,
since that.
so even the contractors can be welcomed into the BIM environment, and they can be able, to collaborate easily and also share information more efficiently. So I will proceed. So who are the typical users of Revit? As we have stated earlier, Revit is used by architects, structural engineers, the MEP team, interior designers, landscape architects, construction contractors, and also project managers, just to mention a few. So once, for example, if an architect has a model in Revit, the structural engineer can take over from the architects and be able to build their structural model from that particular model. Also, the interior designers will be able to access that model and also get to do, to do their things there and end up with satisfying the client's needs. All right, so we will proceed. So here are a few things that you can do with Revit. You can do 3D parametric modeling, as you are going to be doing today, multidiscipline coordination, modeling structural components such as beams, columns, slabs, etc. You can also model your rebars. We are going to get into this tomorrow. So tomorrow will be all about rebar modeling, and then design iteration and visualization. Say, for example, if an architect is in the concept phase of their design, they can be able to iterate and get to come up with, with a final model that they will allow you to proceed with. Then we have the structural steel modeling and documentation. Then the MEP modeling and detailing. So the mechanical, electrical, and plumbing team can do the analysis and also get to model their systems, e.g. the cooling systems, and the fire extinguishing systems. They can be able to do all that in Revit, and they can be able to use the same model that you're working with, or the same environment that you're in. All right, so these are a few this is going deeper into what we have stated earlier. So this is just an example of a project that we have done in Revit. It was an RC structure with some roof detailing or some steel trusses for the roof. So you can see you can model the slabs, you can model any type of a slab that you need. If you need a slab at grade, for example, you are designing a stadium or you're designing a church, you can get to do that. All right. Then we have Revit for steel structures. So Revit allows you to model your steel structures, model the connections and all elements that you would need for your steel projects. And it also makes the documentation part of steel detailing really, really easy. And it also allows you to export your model to other softwares such as robots and advanced steel for further design or detailing as well. All right, so we are also going to do a bit of timber detailing and modeling. So we are going for our roof structure. We are going to use some timber trusses and purlins, and we are going to dive deeper into this once we start modeling. All right, so you can also use Revit in bridge design. Say you can build your model in Revit, but this workflow will also require it will require some more experience, as it will require you to build most of the families from scratch. So you'll get to understand what families are. Families are just predefined reusable 3D models of building components such as beams and columns that we use in Revit. So uh, by default, Revit may not or will not come with certain families such as spires, since they are not are commonly used. And if you needed to create such a bridge, you need to make some of these families, by yourself. So in the near future, we are going to be holding more webinars to go deeper into family modeling once we get the basics right. So don't worry about this, we'll have you covered. All right, so you can also do this for other unique RC structures such as retaining wall modeling. So you can model your retaining walls. You can use the shear walls in the software, or you can also create your own families for the retaining walls so that you always have something parametric to work with, so that you don't always have to start from scratch when you have a new project. All right, so back to sprint details. So we are here at day one, and this is what we are going to be covering. We are going to get familiar with the Revit interface and tools. By now, we are assuming that most of us have not interacted with Revit before, and we want to ensure that by the end of this first session, everyone is really, really familiar with what the interface looks like and where you can find the tools to facilitate the workflows that you want to carry out. Then you are going to set up a basic structural model. I think Captain Glaciers and Hans, you can share the PDF that you are going to be using in our WhatsApp channels. So if you want to follow and model on your end, please download that PDF file that is going to be shared by the two captains and follow through. So we are going to model the columns, beams, and foundations, and also the slabs, and understand how other dynamics in the Revit software, how they come together. All right, then for the day two will be all about reinforcement modeling. We are going to model reinforcement for at least all elements. We're going to ensure we model reinforcement for at least one foundation, one column, one beam, a part of the staircase, and if time allows, also a part of the stairs, a part of the slab. All right, so that we give you a good feel of what you're going to be doing. So when we said sprint, we're going to literally sprint through the entire software. And then day three we are going to do it's going to be all about roofs and documentation. So it gets to show you what you've been doing, how you can transfer all that you did on day two into the paper space, which is a really, really important step, since this is what you're going to be transferring to the client as well as to the contractor to actualize the project. So I'll go to my Revit software, but before I do, I'll allow one person to ask a question. If you need any clarification, this is your opportunity to do so. And I'll only give you a second, since we have a lot to cover. Anyone with a question? Any clarification required from me?
Hello, good
Super.
evening. Good evening, engineer.
Hello, Ahmed. How do you do?
Fine, thank you, sir. Yeah, my question is based on the roof, the details, roof and documentation.
Yes.
So, is it that are we going to get the estimate quantities of in the roof now we have the ridge and we have the gutters, we have the pole lines, and yes. So, based on the spacing of how we are going to be installing it on site, is it that is
Yes.
here now, are we going to get the each quantities of the numbers of the ridges, the numbers of the pole lines, or how? Based on the
I ask
roof details.
a, a good question, Bello. The beauty of using Revit is how powerful it is when it comes to documentation. And once you get to model anything in Revit, you don't have to put any effort into producing the quantities. It's only a few clicks here and there, and you'll get your quantities. So if
Oh,
you if you are patient till Friday, we'll get to show you how you can do that.
okay, okay. Thank you very much.
Super. So I'll go into my Revit software. I hope you can see my screen. Can you see my screen?
Yes, sir.
Okay, just a moment. Okay, so this is the Revit software. Once you open Revit, this is the starting page that you are going to meet. And on the top left, we have the Revit symbol. So if you click on it, it's a button. You can use it to restore, the size of the size of your model, or you can use it to adjust the size that Revit occupies on your desktop. You can also use the maximize here, as you've done in other softwares. And then just on your left, you have two options over here. You have the models and the families. So Revit comes with two environments. In the models, you are allowed to create a new model from scratch. And then in the families, you are allowed to work with families or in the family environment. You can open an existing family and make edits to it, or you can also create a new one from scratch. Similar, you can do the same for models. You can open an existing model or create a new one. And then we have the recent files. So on my right, you can see the recent files I've been working on. Most of them are works that have been done by our former or our current participants, and we'll be going through one of them, and then we'll get to model what we have for you today. So I'm going to open a new model, but before I do that, let me open this train as well, so that you can have a better feel of what our participants got to do. So they modeled this structure from scratch. They started with BIM collaboration workflows using the typical files or formats that are used by people in the AEC industry, such as CAD files, IFC files, PDF files, and also RVT files. We show you how you can start off your model by linking them into your project. And then after we have built our project, we modeled rebar for each element, the beams, the columns, the foundations. So I think I could open one of these sheets. I hope it doesn't load too much. Okay, so you can see what they did. They did a really, really good job. And if you'd like to reach this level of expertise, you could choose to join us. All right, so let me close this. We also managed to create our own custom title blocks, which looks really, really good. So let's go back to the starting page. So the first thing when it comes to modeling in Revit is choosing the correct templates. So we are going to start creating a new model. I hope the PDF has been shared. So uh, so we are going to start with creating a new model. So to create a new model, you'll go to the left side, you have models, and I want you to scroll down to new. All right. Here you'll be able to create a new model, but before you go into the modeling space, you will have the new project dialog box appear. So this dialog box prompts you to select a template that you're going to be using. So if you have your own templates, you could get to choose that. But for this training, you're going to be using the default template that comes with Revit. So as I was saying, the first step in being successful with Revit is choosing uh, the right the right templates. So templates are loaded with families and built-in constraints and parameters. So picking the right one, which or the template that promotes the type of workflow that you want to do is really important, and it will save you a lot of time down the line. So I want us to work with structural analysis default GBRENU. I want you to select structural analysis default GBRNU. And if you do not have it at this point over here, all you need to do is go to browse. And then once you go to browse, I want you to click on this drop down over here and scroll to templates. Then I choose English. And then once you choose English, you can scroll down and look for the default GB, structural default GB RNU, structural analysis, default GB RNU. So something else that I should mention, these are all families. And if you do not have these families installed in your laptop, all you need to do is go to the Autodesk store. You can search autodesk.com and then go to the products and services section and scroll down to the product that you want. So for us, I'm assuming if you do not have the families, you'll scroll down to Revit and then click on these view details. And then after it opens up, I think my internet is a bit slow. Just give me a minute. Okay, so after it opens up, you can get to choose the version that you are working on. So for example, I'm using version 2025. So I'll scroll down to available downloads and select libraries over here. And then once you select libraries, you can scroll down and find the content that you need. So if you are working in Kenya or countries that use the metric system, I advise you to go for the UK English UK content. So let's look UK English content for Revit 2025 and get to download it. All right, so let's go back to Revit. So after we have selected our structural analysis default GBRNU template, we are going to click on open and then okay. Ensure under create new, it is at project, then click on okay. All right, so after you do that, this is how the Revit user interface looks like. This is what you are going to have. So before we start any modeling, let's get accustomed to the user interface. So to the top left, we have the Revit symbol. We saw what it does. It changes the size that Revit occupies in your desktop. And then just right next to it, we have the home button. So this takes you back to the starting page, and it also takes you back to the modeling space. All right. And then to my right, I have the information center. I hope you can follow my cursor. We have the information center over here. We have the Autodesk Revit. It shows you the version of Revit that you're using, then followed by the project name, and then the level that you are working on. So by default, Revit comes with 2 levels, but we'll get deeper into that. And then as you move right, you'll see the Autodesk account that is logged in and also the Autodesk App Store if you need to purchase anything. And you can also access help. So you can come here to access help, or you can also click on F1 to access help. All right, then just below the top part, or in this other top part over here, we have the ribbon. So I hope you can see where we have a lot of tools over here, where I'm trying to circle with my cursor. So this entire part is called the ribbon, and it stores all the tools that you are going to be using as you work in Revit. So the ribbon is broken down into tabs and panels, and the breaking down or the grouping, it's just tools that are grouped together that facilitate similar workflows. So each panel or each tab contains tools that facilitate the same or similar workflows. So for example, the first uh, five the first 5 tabs, we have the different type of professions that work in Revit. We have the architects, the structural engineers. Well, you can do RC over here and also steel over here. Then if you're working with precast, you can choose the precast elements over here. And if you are a mechanical engineer, here is where you get to select the tools that you need. All right. And then from insert all the way to modify, these are uh, tabs that contain tools that can be used by anyone working in Revit. So a common misconception that I had or I had faced as I started working in Revit is that I thought once you choose to work in the structures tab, you cannot use tools in the architectural tab. So you can get to do that, and we will show you how you do that. So as we go through the user interface, something that I'd like you to note, I don't expect you to try and the names of these tools or where they are found. I just need you to be quite familiar with them. And as you get to use the software and interact with the tools, they'll just stick in your mind. You'll just get to know where they are automatically. So don't expand. I don't expend a lot of energy trying to, to cram the names and the functions of each, of each user, of each tool. So again, we are going to start with the architecture. We are not going to go deep into that since we are going to spend most of our energy in the structural tab. So in the structural tab, we have, we have panels that contain tools that we are going to be using. So in the structures panel over here, we have the elements that we are going to use to build up our structure or our superstructure. So we have beams, we have walls, columns, floors, trusses, presses, and also beam systems. Then here we have the steel connections. You could choose to work with them from this part over here, or you could also do them from the steel tab if if you choose or if you want. Then we have the foundations. So once we get to foundation modeling, we are going to use this panel over here. And then in the reinforcement panel, we have the various ways in which you can work with reinforcement. Say you can model rebar, you can model structural area reinforcement if you're working with a slab or something of that sort. Then you can sketch the structural path for rebar. You can also work with fabric areas, fabric sheets, and also provide cover for your rebars. Then you can load components. We are going to get deeper into this, and you can also create openings. Right, so I think that's one of the most important tabs for us. The next one will be annotate. So here is to do with everything annotation, be it dimensioning, be it creating, uh, creating field regions and masked regions, creating components, and also, tagging your stuff on Revit. This is the tab where you're going to be doing all that. And then for the view tab is also another important part in Revit. So we are going to work a lot with sections, and also we are going to be creating some structural plans. So I want to go deeper into explaining this. We are going to just experience them, and then we are going to get the hang of it. All right, so to my left, I have the properties tab. I hope you can see it. So I just moved it. So to my left, I have my properties tab. This will show you the properties of an element you've selected. Say if I was to place beam over here, okay, just arbitrarily, if I was to place a beam over here and select it, you'll notice that the properties tab changes, and now it shows me the constraints, the geometric position, structural dimensions, and identity data pertaining to this particular beam or pertaining to any element that you may have selected. All right, and if you've not selected anything in the working space, it shows you properties of the structural plan that you are in. So at the moment, it's showing me the properties of the level 2 plan. All right. Then on my right, I have my project browser. So the project browser is basically a navigation tool that displays the hierarchical list of all elements within a project. So you'll find it kind of lists everything in a very orderly way, ensuring that you can access any tool or any family that you need, that you have in your, you have in your project. So you can see our structural plans are just over here. We have our 3D views. At the moment, you only have an analytical model. Then we have elevations. We are ready to create any legends, but you can see where our schedules will be, our families. So these are all the families that are in this template. And if we get to add any new families, they'll appear over here. And another cool feature of this project browser is that everything is collapsible. So you can collapse everything so that it does not overwhelm you. Super. So this is the working space that you're going to be using. So let's get started. So let's start modeling in Revit. So I'll try to go as slowly as I can and also try to cover as much ground as I can, since we only have 3 sessions with you. So this is what we are going to do. If you have any questions, please feel free to share them in the chat box or in our WhatsApp channels, and the captains will get back to you. Okay, so let's get started. So this is the file that you are going to be working with. I hope it has been shared in the WhatsApp channel. So Captain Glaciers and Hans, I hope that has been done. So we are going to model this structure from scratch. So we are going to start with creating the grids, then we are going to create the levels. So we have the spacings. How we are going to create the grids is center to center of the walls. And then for the levels, we are also going to do the same. So let's get started. So to create your grids, you can do it in the architectural tab or the structural tab. But since this is the first time you are using Revit, I want us to put more focus on the structural tab so that we can get quite accustomed to it. So to draw the grids, all you need to do is come to the grid tool over here, or you can type GR to activate it by the shortcuts. So I'll place my first grid. I will place my first grid over here, just vertically. I will ensure it's at 90 degrees, and then I'll finish. All right. And then after I have placed my grid, there are a few changes you can make to this particular grid. So for instance, if you want to have a bubble at the top and at the bottom of your grid, all you need to do is select your grid. Go to edit, select your grid, go to edit type, and then here you can make. Please ensure you are muted. You are missing the session for all of us, whoever is speaking on a phone. Okay, I'll repeat that. So if you want to make changes to your grid, select your grid, go to edit type, and then in the type properties, here is where you can make changes to your grid. So if you want symbols at the top and at the bottom of your grid, you get to check this box. All right. If you want to change the color, you can change it at this section over here. Okay. Click on apply and okay. And you can see we have changed the color. So I'm not telling you to change the color. That was just a demonstration. You can also change the type of the line, and you can also get to change the head that has been used over here. Okay, so I will proceed. So we'll get to model the grids that I'm working with are these grids that are running along this direction, the number 1, 2, 3, 4, 5, 6, 7, and 8. So if you have the PDF file with you, you can follow along. So let's continue creating our grids. So I'll go to the grid. This time I'll use peak lines, and then I'll enter the offset distance. This is the offset distance I'm using is the distance between the grids. So the distance between grid 1 and grid 2 is 580 millimeters. And that's what I'm going to enter first. So 580, and then I'll select my first grid, and then my second grid will be there. I'll go back to the offset and enter the next distance. I believe it's, what distance is this? 4020. So I'll enter the distance, 4020. The units are in millimeters, not meters. Then we have 3400. Okay, then we have 2364. And then we have 3400 again. and 40/20. Then we have 580 again. So our structure is really is symmetrical about this direction. I think this is the Y direction. So it's symmetrical about that, and that will really help us make our work a bit easier. So the next thing that we're going to do is model the other grids. So I'll place a grid running along this direction. And then the first thing that I'm going to do is change the annotation of this grid. So you can change the annotation of this grid. All you need to do is zoom in, left click twice on the 9 symbol. So if you zoom in, you'll see a rectangle around that 9 symbol or that label. I left click twice, and then you'll have the chance to edit it. I will place an A, and the good thing with Revit is now it will adopt this and it will label the other grids for me appropriately. So to continue modeling the grids, remember you're working in the structures tab and going to the far right under data, select grid, and then select the peak lines. And then we are going to use the offset tool over here. So the offset here will be 980 millimeters at the distance between the first two grids. And then it will be followed by 2190. Let me confirm. I might be doing my things. Okay. Think we are good. 2190. And then I have two 1420s. So first 1420 and the second one. And then 3520. And finally, I believe it's 70. Okay, so after you have this, you can now make edits to this so that you use the model space more efficiently. Also, this will affect how your drawings appear on paper, and you don't want to have your grids being this way. So what you do is select any of the grids, and then if you zoom in, there's this circular grid. I want you to left click on it and then move it towards the rest of the grids. Ensure they are, sufficiently spaced, and what you have actually, makes a lot of sense. And then after you have this, after you have something like this, you can be able uh, to do it over there. If you'd like to move this, you could also move it to somewhere more central if you want, but that's not, it's not necessary. So after you have your grids, you'll notice at some points these bubbles, they, how do you call it? They overlap, and this is not good. It will not be clear on site. So what you can do to clean this up is select the grid. And then if you zoom in, there's this add elbow function over here. I want you to select it. Just click on it, and then you will have an elbow. And then after you add an elbow, you have this circular grip that you can use to make edits to your grid. So I'll demonstrate that again over here. Select the particular grid, zoom in, you have an add elbow over here, and then just add an elbow. I'll do the same on the other side, and then just move them appropriately. All right, so you can do that for all areas where there's a bit of brushing. You can do that for all areas where you need a bit of, there's a bit of brushing. But for this one, I'll just do for these few areas, and then I let you proceed just for the interest of, in the interest of time. So after you have placed your grids, the next thing that you're going to do is create the levels. So what I mean by the levels is the distance or the floor height. Say we want the distance between the ground floor and the first floor, the distance between the finished floor levels for the first floor and the second floor, and then for the second floor and the roof level. And we are also going to include another elevation for our top of foundation. Right, so let me explain the top of foundation and how it works in Revit. So I'll open this drawing. Just bear with me. I'll go to one of the sections. Let me look for them. I'll go to one of the elevations, and then I'll try to explain how the top of foundation works. So this is the top of foundation. This refers to the level that lies just above your foundation. So as you model your foundation, it will go from this level downwards. So if you have a foundation of, say, a foundation that has a depth of 400 millimeters, it will be modeled from the top of foundation going downwards. All right, if you have a deeper foundation, it will also be done the same way, but it's going to go just deeper than the other foundations. All right, so let's go back to our model. I want you to expand the elevations and then go to any of the elevations, say east, and left click twice to open it. All right. And then after you open it, you will notice one thing. Now you have access to the level tool over here. You will not have access to the level tool if you are working in a plan view. All right. I cannot activate I cannot activate it in a plan view. So to activate the level tool, you have to be in one of the elevations. And then once you're in one of the elevations, just activate it. And now that you're quite familiar with working with the peak lines, you can be able to add a few levels over here. Say, there are two ways in which you can add these levels. You can add it by adding a line manually. So we can say we want this level to start from here to here. You can add it manually. And the good thing with Revit is that you do not have to be very accurate with the distances. It's really easy to, to edit them. Say for this particular structure, I think the floor height was 3,300 millimeters. So the moment we have 3,000, all you need to do is select this particular grid. And then once you select it, you'll notice that the dimension label becomes highlighted. I want you to left click on it and then enter the distance that you require. Then press enter. And now Revit will do the rest for you. All right. Then the other easier way of doing this is just going to the level tool, use the peak lines, and then enter the offset distance, 3,300 mm, and then create a level for the for the second floor and another one for the roof. All right, and then let's do another offset for the top of foundation. So I want you to move to the level one, and then move your cursor from the bottom going upwards. So something that I should have mentioned, if you approach this level or a line that you want to offset, it will be offsetted in the direction that your cursor is your cursor is coming from. So if you are approaching this level from the top side, you'll notice your line is being formed in the top side. But if I was to approach this level from the bottom side, you'll notice that my level is being formed in the bottom side or on the lower side of level one. So I want my top of foundation to be formed 1.5 meters below level one or our ground floor. And so I'll approach it from from the bottom. So also be careful, don't left click twice. Sometimes you can create additional levels without actually you knowing. And then after you create levels, please extend these ones downwards. Ensure they cover all the levels. If you don't do this, you'll go to one of your structural views and then you'll find that you do not have your grids over there. So once you create your levels and notice that they do not extend beyond all the levels, just use the circular grids to ensure they extend through all the levels. And again, similarly to what we did with the grids, they also have the edit type over here, and you can make the same changes. All right. You can have the same levels and then you'll be good to go. All right. Okay, so we have that at this point, and I think we are good to go. So again, for these views, you don't have to make changes in all of them. You only need to make them, this change in two of them, probably the east and the north, or east and south. So yeah, just extend this here and extend this here. And then we are good to go. All right, so we have this, and now we can start modeling. But before we start modeling, we should rename these ones so that we know the plans that you're working on. So we said the first one will be the top of foundation. Then this one will be ground floor, right? And then let's call this one the first floor. And then we have the second floor over here. And we have the roof over here, all right? So I only need to do this in one of the elevations, and it will update through the entire structure. All right, so the next thing that we need to do is create other structural plans. You can notice, or you can see, only have plans for the ground floor and the first floor, and you'll need details for the other plans as well. So if you do not have other plans and you'd like to have them, all you need to do is go to the View tab. And then once you are in the View tab, I want you to go to Plan Views, and then go to Structural Plan. And then in the Structural Plan, I want you to select the plans that you do not have, and then click on OK. Please ensure that do not duplicated existing views is on, and then click on OK. And if you do that, now you'll notice you have all the plans that you need. All right, so I'll close the views that I'm not using. And then we can start modeling our structure. So we'll start with the top of foundation. So we are going to start building our structure from the top of foundation, going upwards. And we are going to start with the columns. All right, so something I should explain. We are working with families. We are not going to be doing 2D drafting as we would do in AutoCAD. So by families, remember we introduced what families are. We say they are predefined, reusable 3D models of building components. So they are building components that are already in 3D. Yeah, in 3D, we mean they have data in the X, Y, and Z coordinates, and they will help you build up your structure. So let's make our first column. So to create or to model a column, ensure you're in the Structures tab, go to Column, and then once you go into the column, you notice the properties changes. Then click on this drop down, and then select the type of column you want. If you're working with a steel structure and you need some circular hollow sections, you can get to select them from this part over here. Also for the concrete rectangular columns, you can get to select them from this section over here. And if you're working with universal beams columns, you can get to select them over here. If there is a type of column that you'd like to work with and you do not have them over here, all you need to do is go to the load family, and then just as we did before, but now you're going to go to a different family library. So you're going to go to English, UK, and now select structural columns. And then here you have more options. So if you want concrete columns, a light gauge steel column, a precast concrete column, steel or wood, here's where you get to load them into your projects. All right, so let's continue. We are going to be working with a concrete rectangular column, but you'll notice it only comes with 3 predefined dimensions for our column. And typically this won't be sufficient for you. So if you want to create a new cross-section for your column, all you need to do is select any of these cross-sections and then click on Edit Type. So the first thing that you're going to do is you are going to change the properties of this column. But in Revit, before we make any changes to any particular family, we always advocate for you to duplicate first. Why do we advocate for you to duplicate it first? The reason we advocate for you to duplicate it first is that if you make a change to a particular family and then you find that that change was not suitable and you'd want to have the original family, you'll have an original family to go back to. So you won't have to go through the entire cycle of having to load the family afresh. All right. So let's make our first column. So I'll repeat that. So let me repeat that. If you want to model a column, go to Structure, Column, then click on this drop down, select the type of column we want. We want the concrete rectangular column. So we are going to select any option over here. Then go to Edit Type. And then the first thing that we're going to do is click on Duplicate. And then we are going to be prompted to rename it. So I could say this is column 1, and its dimension I will input, say, 200 by 450 millimeters, and then click on OK. So what we have done is just that we have renamed it, but we have not changed the dimensions. So we need to change the dimensions. So to change the dimensions, you scroll down to these dimensions over here, then move right and left click. Once you left click, it becomes highlighted and you can now type the dimension you want. All right. So this one is already 450. I do not need to do that. So click on apply and then OK. And then before you model your column, there are two types of columns you can place in Revit. You can place columns you can place vertical columns, or you can also place slanted columns. There are also automatic ways of creating columns. So you could create them at grids or at columns, or at architectural columns. All right, so you could get to do that. But before we make any placements, let's talk about these options bar over here and the parameters that it has. So from the left, you'll see the first thing is modify place structural column. So this tells you what family you are working on. So if I was placing a beam, it would tell me place structural beam. All right. And then if I wanted to rotate my column after placing it, I would check this box. But at the moment, I do not want to rotate my column. And then we have column placement options or column modeling options. You can model a column by depth or by height. And to explain that, I'll go to one of the views. So by modeling a column by height, it goes from one level going upwards. That is by height. You model your column from, say, ground floor going to the first floor. That is modeling the column by height. But if you are modeling by depth, it means it goes down from the level you are working on. So if you are modeling a column at the first floor and the placement, the modeling option is under depth, it would go from the first floor downwards to the ground floor. All right. So let's go back, column, and then now let's place it. So I want to work with height. We said we are working from down going upwards. So we are on the top of foundation. We want our column to go to the ground floor, then the first floor up to the roof level. So height, then I will constrain it to the ground floor. And then after I do that, I can place my column where we have these grids, intersecting. All right, so you can place columns. All you need to do is place them. Just click anywhere and a column will be placed. It doesn't have to be where the grids intersect. The grids are just a way of, helping you find where you want your columns placed. So I will quickly place the columns so that we can proceed to the other parts. Also, okay, so I'll proceed. So I'll place another column. I'll select this one. I could choose to copy it, but I want to create it afresh so that this sticks or it reinforces what we have done. So to model a column, we go to Structure, Column. If you do not have column, family selected, just choose any family over here and make the edits that we made earlier. So select the column that you want to place. Remember, before you place them, ensure these constraints are set how you want them set. So for me, I want to work by height and I want it constrained to the ground floor. So for this one, I'll also check the rotate after placement so that I can demonstrate something. So if rotate by placement is checked and I placed a column over here, before I exit from placing the column, Revit prompts me to rotate it. So I'll just do this and then enter an angle of 90 degrees and press enter. And my column is rotated. All right. I can repeat that column then place my column at this intersection. Sorry, I did not check rotate. So check rotate, place your column, and then you are prompted to enter an angle. So I'll choose 90, then press enter, and my column has been placed. So I'll place the other columns really quickly. So I'll just select this one, ensure the parameters are okay. So top of foundation and ground floor, and then I'll just copy them. I'll copy them by the center and place them over here. So I could also place one here, another one here, another one here, and another one here. Let me see how the architectural plan looks like. Okay, let's see that. So I'll place one here, another one here, and another one here, and then I'll delete this one. All right, so we have placed columns over here. And if you went into any of the views, you can see columns from these extending from the top of foundation to the ground floor. We could also open a default 3D view. So if you are to look for this quick access toolbar over here, you have this heart symbol, which opens the 3D view. Also, this is the other way in which you can open the 3D view. Go to view and then select 3D. Just click on it and you'll have a 3D view of your structure. So I want to show you something else. So instead of having to model these columns in this other side of the structure, since it's symmetrical in this direction, we can do something cool. So I'll go to annotate and then I'll draw a line. So I'll draw a detail line and I'll just draw it arbitrarily. So I don't need to be very accurate. I let Revit do that for me. I want Revit to do the heavy lifting for me. So after I place the detail line, I'll select the aligned dimension over here and place that dimension from the first grid to this line that we just drew, and then to the last grid. And then after I do that, zoom in, there's this equal symbol over here and left click on it. And once you do that, Revit places that line at an equal distance from both grids, all right? And then after you do that, select all the columns that you just modeled and then mirror them. Use the mirror tool and mirror them up by this line, all right? And once you do that, they become modeled on the other side of the structure as well. And you can see them in the 3D view, okay? So that is that. Then let's get to copy these columns to the other views. So if you are copying the columns to other floor plans or to other levels, I recommend you working in the elevations. So I just want you to go to any of the elevations and then highlight from top left to right, and just highlight the columns that you want to copy. And then select those columns. You'll notice that the contextual ribbon changes. I want you to go to the clipboard panel, then select copy, and then you have the option to paste. So select aligned to levels. I'm prompted to save the project, so I'll save it. Okay, so just a moment. Now I'm prompted to select a level to copy them. I could choose to copy them to the ground floor. Sorry, I'll undo that. Okay, so let's do that again. I'll go to one of these levels, select all the columns, then copy them, and then paste them to aligned selected levels, and copy them to the first floor, and then click on OK. So when copying column using this method, it models them from the first level going downwards. So that's something that you should note. So you'll notice that it copied them from the first floor going downwards. All right. Then after they have been copied in this manner, you need to change the settings so that, they suit what you want. You want to extend them up to the ground floor. So highlight all of them only those columns in the first floor, and then go to properties. Ensure the base level is the ground floor. So we can change this, go to the base level, click on this drop down, select ground floor, and then for the base offset, ensure it's at 0 and the top offset is at 0. All right, and then click on OK. And then your columns are modeled more appropriately. Okay, so we have that covered. I will then go back to my elevation view. I will select these columns again in the ground floor to first floor. I use the same copy to clipboard tool, then go to paste, align to selected levels, and now I can select the second floor and the roof, and then click on OK. And by doing that, I now have all the columns modeled for the entire structure. All right. So that was easy. So now let's do the beams. I'll model the beams from the first floor. So to model the beams from the first floor, I'll go to, again, Structure. Now we are in the Structures panel. We are interested in modeling an RC beam. We are going to select beam over here, and then we'll click on this drop down. And once we click on this drop down, now the workflow becomes similar. You'll select any of the beams under the concrete rectangular beam, select any of them. And then before you place them, just go to edit type and get to edit the type. So let's duplicate first. Remember, the first step is always duplicate. And then after you click on duplicate, you're going to be prompted to enter a name for the new, for the new family. So we could call this B1, say 200 by 450 mm, and then click on OK. All right. So we've only changed the name, the type name. Then the second thing that you'd need to do is to change the dimensions. So change this to 200, the breadth to 200, and then the height to 450. All right, and then click on apply and OK. Okay, so we can start modeling our columns, our beams, sorry. So to model them, I just start with the easier ones. So I know I have a beam over here. Oh, sorry, as you model them, there's something that I should have explained. So we want to model our beams. In the options bar, we have the same constraints. We want them here. Remember, I elaborated this earlier. It shows what item you are working on. So if you are working on modeling, columns, it would be model column. But now we are working with model beam. It's now showing you place a beam. Then the placement plane is the level we are on, the first floor, and then the structural usage. Leave it as automatic, and then also leave this as chain. All right. Then for the geometric positions, YZ justification. If you want your beam inclined, set as independent. But since we want this in the same, in the same plan or in the same level, we are going to leave it as it is. All right. So let's model our beams. I'll select the first one. And then I'll continue to, to place the others. Okay. Okay. So after I place these ones, I can choose to select them. I can choose to select the beams I just modeled. Then I use the copy tool to copy them to the other grids. Then I'll do the same for this part over here. Let's see what we have. Let me have a look at the PDF file that we're working on. So I can connect this one. Okay. So let's do that. I'll go to the structure tab again, beam, and then I'll just connect these two here, and then these two over here, right? Then I'll connect this one over there, and this one over there, all right? I'll do the same over here. I remember you can always mirror this, but just for demonstration purposes, I'm choosing to do them more manually. Okay, so we have this at the moment. Let me have a look at what we currently have. Let me have a look at what we have in the PDF file so that I can know how to place the other beams. So I'll open my PDF file. And then I don't think I've placed a beam over here. Okay, so let's zoom in. Okay, so I have a beam in this. Okay, so let's model that one. So we have a beam here. Okay, so we have a beam over there. And then something that you might notice, here we have, we can place a beam over here since this is an opening. So we're going to place a beam over here, but we do not have a grid for placing it. So I want to show you how easy it is to do this in Revit. I'll just zoom in to check the distance. It's 1100 from the edge of the beam to the other edge of the beam. So what I will do is just come to this section over here and model beam arbitrarily. So ensure it extends into the other one. All right. Okay. Then I'll just model a beam arbitrarily, then place a dimension, then click outside. Then after you place that dimension, select the second beam and enter the distance that you need. And then after you do that, Revit will do the rest for you. Now you can delete these, you can delete that dimension since you do no longer need it. And then you're good. Then you can copy these two from this section over here to this section over here. And now you have, the lower part done. So let's finish the upper part. So let's do the same thing. So we have a beam over here. Same. Now let's model a beam over here. And then we are going to place another beam over here arbitrarily. Then you are going to place a dimension. And then after you place that dimension, let's go to the PDF file. And let's see the distance they have. They have 1369. So I'm just going to work with that. I'm going to select this beam, zoom into this dimension, and enter the dimension. And then after you enter the dimension, just click enter, and your beam will be moved appropriately. Then delete this dimension since you no longer need it. And then now draw other beams to connect these two beams. All right. And then after you have that, you can now, after you have that, you can select all the beams in this section over here and copy them from this grid to this other grid since they are similar. All right, I think we have another beam here that I'm leaving out. Over here, we can have a beam over there, so I'll just place it. So I'll just place beam over here, and we are good to go. So that's how easily it is to model your beams. So I think I also forgot another one over here. Let's see if we have any other beams that we are missing. I think we are good, but we can add, we can cross these ones. Okay, so we have those beams over there. We could probably add another one over here, just to have it be continuous if you need. So we have those beams over there. You can see how easy it was to model. And if you go to a 3D view, let me change the visual style to shaded. You can see how, how it looks like. You have your frame coming really well. So the other thing that you can do at this point is just zoom in, select any of the beams, right click. Then once you right click, you have the option to go down to select all instances or select similar. So let's go to select all instances. Sorry, right click, then go to select all instances in project, and then all your beams will be selected. And then after you select these beams, all you need to do is copy them to the clipboard, then go to paste, and then copy them to selected levels. So we need them in the second floor, and the roof. Click on OK, and you're good to go. So you can see how easy it is to do. We have probably modeled our RC frame in less than 28 minutes, I think. So you can do that. So we have modeled our RC frame. So the next thing that you're going to do is to model our slab. So I'm going to go to the first floor. And then in the first floor, I'm going to go to structure. And then I'm going to use the floor over here. I'm going to click on this drop down and then ensure I'm going to use the floor structural. And then after you choose to add the flow structural, before you model it, remember we are always duplicating and editing the families to have what we need for our project. So for this project, we required a flow of 150 millimeters depth. So we are going to click on edit type. All right. Then you are going to duplicate this. We could call it a reinforced concrete slab 150 millimeters just to communicate, and then click on OK. So the first step is to always rename, to give it a duplicate, then rename. Then the second step is always to enter the thickness that you require. So to enter the thickness that you require, you click on this edit option over here, go to thickness, and then enter the thickness that you need. Click on OK, apply, then OK. And then after you do that, you have the chance now to model your slab. So this is how slab modeling is done in Revit. You're not going to be modeling the slab. What you're going to be doing is you're going to be drawing the boundary of that slab. So you're going to be drawing the boundary, the outer edge of the slab, and then Revit is going to model the rest for us. So let's draw the boundary of our slab. I'm going to use the peak lines over here. And then I'm going to be picking lines along my beams wherever there's a change in direction. So at this point, you can see this beam is going this way. Then I picked another line so that it goes this other way, then another line going in this direction. So pick a line whenever there is a change in direction. So for this one, you can see a slab is moving downwards, then right. So I pick another line moving downwards, then here it will move to my right, then downwards, then it will go back to my left, then downwards, then to my left. Wherever there is a change in direction, all you need to do is select a line going in that direction. All right. Okay, so I do that. And then do this. All right. So after you have done this, something that I should have mentioned, the boundary should always be a closed loop. So a closed loop is something that looks like this. It should always be closed. The lines should always, close each other. It always be in a closed loop. So at the moment, you can see our lines are really not closed. They have breaks. So this is another easy thing to do in Revit. If you are using AutoCAD, you'd probably have to extend this, then extend this, use the trim tool for all sections, and it would be really, really tiresome. So with Revit, that has been automated. All you need to do is go to the modify panel, and then pick the trim extend to corner. So this extends and it trims lines for you. So you can see it just extends it and trims it for you. So all you need to do is select your lines, in a progressive way, moving in one direction, so that you don't, so that you do not miss any line. I recommend working in a clockwise direction. So just do this and then ensure the boundary is closed. So select all lines, go join in them. You can see in a minute we'll get this done. Okay. So, okay, so I leave this junction open so that I can demonstrate something. So if I was to have any breaks, or if my line or my boundary is not continuous and I tried to finish, Revit would bring up this error or warning telling me all lines must be in a closed loop. All right. So if this pops up, just click on continue and then go back to Revit. All right. Or if you cannot visualize where that break is, just zoom out a little bit, then try and finish. And Revit will always highlight the area where that break is. So you can see it's highlighted. So all I need to do is continue sketching, use the trim extend tool, and now, close it. And then once it's closed, I have my slab modeled. So if I was to change this to shaded, you could see how my slab looks like. So we'll go into the 3D view, then we can select this slab and copy it to the other floor. So I just select it. Then as we did earlier, copy to clipboard, then click on paste, align select levels and select the second floor. I'll click on OK, and it has now been copied. So that's how easy it is to do that in Revit. So let's model the ground floor slab. So let's go to the ground floor. Left click on it to open it, and then use the slab. Let's create a family for the ground floor. So I'm just going to duplicate this. Then let's call this the ground floor slab, and then click on OK. Click on edit and then change the thickness to 300. So the reason I'm changing the thickness to 300 is so that we can be able to create the layers for our hardcore, our maram blinding, and also our DPC layers or our DPC layers. So I'm not going to demonstrate how to do that, but we will share a video with you to guide you on that. So I'll just click on OK, then apply, and then OK. And then after I do that, I just use this rectangle and place, a boundary just arbitrarily and place it. And then after I do that, I want all my columns captured. After I'm comfortable with what I have, I just click on finish edit mode. And if I went to my 3D model, I can now see my ground floor. All right. So that's how easy it is to model your slabs in Revit. So after we have done with our superstructure, so we are done with the frames for the superstructure. All that is remaining is the roof and the foundations. So let's get to do that. So I'm going to go to my top of foundation, and then I'm going to start with the walls. So to make my work easier, I'm going to go back to the feature that we just did earlier. I will just go to the grid, to the detail that we did earlier. So I'm going to go to annotate. I'm going to place a detail line. I'm going to select a line over here. And then I'm going to add a line here. Ensure it's at 20 degrees. And then use the aligned dimension tool. Place a dimension from the first grid to the line that you modeled, and then to the last grid, and then click on outside. And then before you press escape, zoom in and click on this equal sign. And then your line will be placed in the middle. So this will be your mirror line I don't want us to model all the walls. I want us to copy some of them. All right, so let's click on escape and get to modeling. So let's go to structure. We're going to go to wall. And then as we do for all models in Revit, we go to edit type. We duplicate. Then let's rename this to foundation walling. And then click on OK. So at this point, you just click on OK and then proceed. But before you place your wall, please ensure you go through the options bar over here. You can see now under modify, we are being informed that we are placing a structural wall. And as we modeled as we modeled the columns earlier, we said you're going to model them by height so that they go from the top of foundation to the ground floor. So I will select heights, and then under constraint, I'll select the ground floor. All right. And then for the location center line, I will have it as wall center line so that my wall is placed along the center line of my grids. All right. So let's place them. So please don't be tempted to model them to the center of the column. Yes, Revit will model that for you, but this is not what you'd have on site. Your wall will not go into your masonry wall won't go to the center of the column. It will end at this point over here, where it will end at the edge of the column. So ensure you have that. Ensure as you model your wall, it ends at the outer face of your column. All right. So let's model these ones as well. So model it here. Ensure it ends at the edge of your column. So model from that point to that point, then to that point over there, that point over there, and then let's model to this edge and to this edge as well. Then for these ones, let's use the easier way. So copy them. Copy them. And also for this one, I could just create it from the edge of the column to this other edge. All right. Then let's do the same here. Let's create columns, walling going in this direction. Let's create walling going in this direction. And then after we have created them, let's just select them. Select the three walls and then copy them from this column to this column. All right. And then once you have that, you're good to go. So we're going to use the same workflow. Select any of the walls, right click. Then let's select, I cannot select similar. So I'll just highlight these walls. I'll highlight everything. All right. Then go to filter and then I'll check none and check structural walls only. Click on apply and then OK. And then after I do that, I'll use the mirror peak axis. Remember the axis we drew earlier and just mirror them. All right, instead of having to redo this, just mirror them and you're good to go. And then the other thing that you may want to do is just create another wall in over here and copy them. So copy them to all areas where you may need them. And then you're good to go. So you have all your foundation walling, and if you are to go into the 3D model, you can see where they are. So something that you will have on site is that these walls will not extend to the top of the slab. They'll only be attached to the bottom of the slab. So to do that in Revit or to attach them to the bottom of your slab, all you need to do is select one of them. Okay, then right click and then select all instances in the entire project. So we've selected all the walls in this project by just that one, by just following that, but just on that one click. And then after you do that, I want you to go to the contextual ribbon. We have the attach top stroke base. Just click on it and then select your slab. And after you do that, all your walling will be attached to the bottom of your slab. All right, so let's continue. Let's model our foundation. This will be easy. So we go to the top of foundation, structure, and then we are going to work in the foundation panel. So we are going to work in the isolated footing over here. So as usual, you're just going to click on edit type, a duplicate. Say for this project, let's use 1500 by 1500. Let's use a depth of 450 and then click on OK. And then after you have renamed it, so the next step would be to make changes to the dimensions so that we have what we need. So make changes to the foundation thickness, leave it as 450. The width, let's use 1500, and the length, 1500. Then click on apply and OK. So you could choose to place these columns, these foundations the manual way. Okay, most of the times you'll place them the manual way, but there's also an easier way to place them. So if you want to place them the easier way, what you do is go here to columns, all right? And then you'll be required to highlight an area where there is columns. So highlight an area where there are columns. And then once you have, a layout of how the foundations will look, click on finish, and then you're good to go. And then the beauty with Revit is that it's easy to make changes. Say, for example, for this column over here, you'll realize that after your design, you want to use a bigger footing. So all you need to do is select this foundation, go to edit type, duplicate it. Say you might want to use an 1800, say by 1800. Let's just maintain the depth for now and then click on OK. All you need to do is create a new family for it, 1800 by 1800, and then click on apply and OK. And now your foundation has been changed. All right. If the family was pre-existing your template, you'd need to just select the foundations that you want to have that dimension, select them, go to the drop down, and then choose the family that you want, and they would be updated automatically. So that's how easy it is to make changes to your model in Revit. So we have modeled our pad footing. But the next thing to model should be our strip footings. So this is another easy task. So to model your strip footings, you'll go to the foundations over here and then select wall. All right. Then click on this drop down. We usually have two types of foundation footing of wall foundations in Revit. We have the bearing footing and the retaining wall footing. So for the retaining wall footing, it speaks for itself. It's used where we have retaining walls. And then for the bearing footing, we normally use it for our strip footings. So we are going to select the bearing footing and then click on edit type. Then we are going to duplicate, and then let's call this strip footing, say 600 by 200 mm, and then click on OK. All right, then move this to the right, slide it to the left so that you can see what we want to change. So we want to change the width. We want the width to be, 600 mm. And then we also want the depth to be 200 mm. And then click on apply and then OK. And then after I do that, all you need to do is select your walls and then a strip footing will be placed. All right. All you need to do is select a wall and a strip footing will be placed. So something that you should note, you cannot place a strip footing or a wall foundation where you do not have a wall. So Revit won't allow you to do that. So if you want to model a wall foundation, you have to model the wall first, then model the strip footing. Okay, so that's how easy it is to model it in Revit. And also this will also be your, this will also be your foundation layout. So all you need to do is add a few dimensions, clean it up, and then push it to the plan and product to the paper space, and you have your detailed you'll have your detailed foundation layout. So you can see how easy that was. And then we are good. So let's go to the 3D model. Let's see what we have. We have our foundations, both pad and street footings. Then we have our ground floor slab, our columns, our suspended slabs, and the beams. So let's do the roof. All right. Let's do the roof. I will introduce you to something new over here. So I hope you will follow through. I'll introduce you to a set of Revit settings called the visibility graphics that affect how or whether, first they affect whether items are visible, and then they affect how they are viewed. All right, so let's model the roof first, and then we'll get to see how that particular setting comes into play. Okay, so let's model the roof. We'll go to the architecture tab, and then to model the roof, we are going let's model the roof. Am I still audible? Can you guys see my screen? Someone please confirm. Type a one.
Yes, you can go.
Yes, you can
Super.
continue.
So to model the roof, I remember what I started my presentation with. I said earlier I was under the impression, or as I was starting my Revit journey, I was under the impression that if you are working with structures, you cannot use the architectural tab. So I was, that was just a misconception, but you really can. So for the roof, we do not have a structural family. So we are going to use the architectural family to model our roof. So we are going to go to architecture, and then we are going to select the roof over here. So there are a couple of ways in which you can model the roof. I'm not going to go into that now, but you're going to model it the easiest way. So it's the easiest way is by roof by footprint, and then click on it. And then for this one, let's keep it simple. I'll just use the generic 125 that Revit has. And then I'll go to my PDF. I want you to see what we have. So you can see how the roof is. It is placed between the walls. They probably want some sort of hidden roof. So you will we'll use the interior, I will use the interior dimensions of the beams to place our roof. So we'll go to Revit, then pick lines. So placing the roof works in the same way in which we modeled our slab. All you need to do is pick the lines, pick the boundary, and Revit will do the rest for you. So pick lines, and then before you do anything, ensure you click on define slopes. So I want to explain what define slopes does first. We'll first model the roof, and then I will show you what it does. So let's pick the boundaries of our beams. Okay, let's pick the boundaries of our beams and our roof there. So once you've picked enough boundaries where there is change in direction, then remember our tool here, BIM extend to corner, and use it to extend or to trim and extend the lines. All right. Yeah, so ensure you pick all the lines. And then after you've connected all the lines, all you need to do is click on finish edit mode, and your roof has been modeled. But if you go into the 3D view, you're not going to be able to see it because of the visibility graphics settings that I mentioned earlier. We said that for the visibility graphics settings, they affect whether the object or the family is visible. So to access the visibility graphics settings, you need to go to the View tab, then go to Visibility Graphics over here, and then under Architecture, scroll down and look for roofs. So how this works is that any item or any family that is checked, it means that you can view that particular family. So you can see we cannot see the staircase, and we can also not see the roof. So I want you to check on the roofs and also on the stairs. Click on Apply, and then okay. And after you do that, you can now be able to see your roof. So that's the roof we just created. So I was to explain something. I'll go to the roof tab over here. I'll select the roof. You can always make an edit to the boundary. So I was to explain what the defined slopes does. So if I was to uncheck the defined slope, it means this boundary will not affect the slope of the roof. So if I was to close this and then go to the 3D view, you can get to see how that works. So there's a roof boundary over here, but it does not affect the slope. So it does not cause the roof to slope in that direction. All right. So there's a similar boundary here, but for this one, we checked the defined slope. So let's check it again. Select your line, select define slope, and then finish. And then if you go to 3D now, it defines it. So after you do that, all you need to do is now, you don't need to create a new one. So we'll just rewrite. We'll use the same method we've been using. Just draw a line arbitrarily, use the dimensions to place it at the center. Okay, select your roof and mirror it. And then in 3D, you now have your two roofs. And then at this point over here, they had a slab to store their water tanks. So we're just going to model it quickly. You're going to go to structure. And then you're going to do a floor. And then we are just going to place the boundary here. This time I'm picking the rectangle. So I'm just going to place a slab over here and then click on Finish Edit Mode. And then if you go into the 3D view, your roof is now complete. Okay, so we have modeled the entire structure. That is what we were supposed to do. So I also want to model the staircase. I want to borrow at least 10 minutes of your time. Can I model the staircase so that tomorrow we only work on river modeling? What do you guys think? Will you guys give me 10 minutes of your time?
Go on, sir.
Go on.
So I'll model the staircase in the first floor. So to model the staircase in the first floor, again, I'll go to the architecture tab, and then I'll go to stair. So we'll keep it real simple at this point. So I'm just going to click on this drop down, and then I'm going to select the monolithic stairs. And then, as we always do, edit the type, duplicate first. So we could call this reinforced concrete staircase, and then click on OK. All right. And then we can make changes to the parameters that constrain the construction of the staircase. For example, the riser height. So you could check what your building code or what your architect has provided you with. So for example, for this project, let's use a maximum riser height of 150 mm. And then let's use a minimum depth of 300 millimeters. And then I leave the minimum run width as 1000 as default. Then the other change that I'm going to make will be the run type. I'll just click on these three dots, and then I will uncheck slanted over here. Then click on apply. Okay. and then I'll be able to model my staircase. So let's model our staircase. I'll pick run over here, and then I will ensure the constraints. The base level is first floor, and the top level is the second floor. So I'll start modeling. So before I model, we did not go through the options bar over here. We have the location line. So what the location line does, it affects where your staircase is modeled in relation to where you're drawing your line or along the direction in which you're moving your cursor. So if I was to change it to my, sorry, if I was to change it to exterior support left, it means where this line is being drawn, where I'm moving along my cursor, will be the left support of my staircase. All right. If I was to change it to, say, a run center, it means the line along which I'm moving my staircase will be the center of my staircase, right? So for this one, we want this direction to be the exterior support left of our staircase, and then we'll get to model it. So as you move your cursor upwards, you can see the number of risers created and those remaining. So just move it upwards until a point where they are almost equal or equal. So you can see we have 11 created and 12 remaining. So I could have 12 created, 11 remaining, and then I end that particular run at that point. Then all I need to do is go to this other run, and then for this one, I want this direction or this line along which I'm moving my cursor to be the exterior support right, all right? So that my staircase is formed on the right. And then I move my cursor until all the risers have been created. And by doing that, I have my staircase. Then something you'll notice, if you zoom in, you'll see that your staircase goes into the beam. This is not ideal. So the easiest way to deal with this is to use the align tool. So we could go to modify. So the easiest way to find the align tool is to type AL. So you could type AL to access the align tool, or you could select it from here. And then I will select the first boundary, the edge of the beam, and then select the boundary that you want to move. You want to move the edge of the staircase. Then select the edge of the staircase and move it. And then click on finish edit mode, and you're good to go. So after you do this, select the entire staircase, and then let's move it to this interior side of the beam. And now we are good to go. So we still have the same problem on this edge. So I'll select the staircase, go to edit staircase. I'll use the align tool again. So select your first boundary, and then I select your second boundary, and then click on finish edit mode, and then you are now good. So if you were to go into the 3D view, you can see your staircase has been formed. All right. So you might want to copy this staircase to other levels. So what you're going to do first is select this staircase. Then you're going to change the constraints. So for the base level, let it be the ground floor. Sorry, let it be the ground floor. And then for the top constraint, let be the first floor. Click on apply, and your staircase will be moved to these lower parts. All right, and then after it has been moved, just select, go to the elevations, any of them, then select your staircase, and then after you select your staircase, go to any of the elevations, select your staircase, and then your contextual ribbon will change. It will change to show you the select levels. So click on select levels. So we want to create a multi-level story staircase. So after you do that, you can click on any of these white levels, but for this one, let's have our staircase terminating at the second floor. So click on the second floor and then click on finish. And then by doing that, you have modeled or your C members. All right, you can see how fast we did that. So I'd like to end the meeting at this point, and then I will meet you tomorrow. I will dive into RIBA modeling for all these elements. So unless anyone has a question, feel free to ask any questions, and then we could get to adjourn the meeting and meet and see each other tomorrow.
Yes, I do have a question on my side. Where can we get access to the recording? Is it going to be saved, and how can we access it if it's going to be accessible?
Okay, so the recording will be shared in all our WhatsApp channels, all our communities. We'll share it to you via email, and you'll also post it on all our LinkedIn accounts. So you'll get access to the recording once it has been, once it has been prepared.
Okay, thank you.
So by tomorrow morning, you'll have it. No worries. Someone else with a question? Anyone with a question?
Good evening, sir.
Hello, sir.
Please, I'll start by thanking you for the class. It was a wonderful one. And my question is based on the roof. Can you hear me?
Yeah, I can hear you, sir.
Okay, it is based on the roof. The roof was done using the interior of the beam.
Yes.
Won't it affect like after construction now, maybe when we have a downpour?
Yes.
Won't it affect the structure? Because most times we normally have like a eaves, like maybe like 600 depending.
Yeah. I agree with you. I see where you're coming from. But as engineers, we carry out our structural design based on what the clients and the architects want. So for this one, since you have access to this file, if you go through the details, you will see that they have provided gutters. They have also provided gutters on the interior side of the roof. So I was just showing you how you can get to model them as per this architectural drawing. But if you are to do it the other way, if your design requires you to have the roof on the outer edge of the structure, you can be able to do it using the same way. So for example, I don't know, I've used your time, so I'll just delete this one and show you quickly. Say you want to have a roof on the outer edge of the beam. All you need to go is back to go to architecture and then roof, then select boundary. And then here is where you want to enter an offset so that you can have your eave. So let's say you want an offset of 600 mm. So you can get to do just the same process. I think by now you can do this. So let me see. So just the same process over here. Okay, and then after you have this, just join them. Okay. Okay, so I have this one and this one, and then I'll click on finish edit mode and go to the 3D view. You can see you have an overhang. Can you see that, sir?
Yes, sir. Yes, sir.
Yeah, so it's the same process. You just use the tools differently.
All right. Thank you so much.
Super. So I really want to end the meeting at this point. I know there are my guys here. If I make them miss today's game, they will not forgive me. So unless it's a really, Chris, I'll let you ask the final question and then we'll adjourn the meeting. If you have further questions, please feel free to raise them in our channels.
Good evening. Good evening.
Good evening, Chris.
I just wanted to ask about the roof plan. How can you edit it so that it looks the way it is in the PDF, the shading, something like that?
So in this PDF, you can see the lines that you have are purlins. So yeah, it will get to look like this once we get to model our purlins. All right. Uh, sorry, I think I get your question. If you want to see the edges of your roof, you could go to the roof level, go to the extents, and then under view range, change the top plane to something high. You could use 10,000. And then for this one, you could also use something higher as well. So 9,000, click on apply and okay. So you could get to do that. And then once we get to model the purlins on Friday, you'll have the other lines cutting across. Is that okay? And Chris?
Yes, thanks.
Super.
Gatimo,
Good evening.
Yes.
I have two questions. This is Paul speaking. First of
Hello,
all,
Paul.
really good presentation and really good articulation of how to use the software. So
Yes,
my
thank
first
you.
question will be, when you're placing your beams, what is the
Yes.
rationale that you use that you're using simply supported beams rather than the continuous beams? Instead of clicking from one end of the column to the opposite end, you're clicking for every single column. And now for the last question is, were you supposed to show, let's say, how to place the shaft in this session, or maybe you're gonna be showing it maybe in the next session? Thank you.
Okay. Thank you. Thank you for those two questions, Paul. I can recognize your voice really clearly. So again, I'll start with the first one. So the reason I was ending the beams at every column or at every support is just because I am, say, kind of used to it. Since if you are to do that in an analysis software, it would give you a lot of trouble when it comes to the deflection checks. So for this one, it would not really affect you since you are going to be using this for rebar modeling. But if you want to export your model to a finite element analysis software, such as Robot or any other software, ETABS, Proto, I recommend you ending your beams at every support, just to give you an easier time as you design. Then for the shaft, it would have been ideal if I got to model it at this point, but I'm going to start with it in the next session since I'm out of time. Sorry. Is that okay, Paul?
Yeah, that's okay. Thank you. Thank you. Really good presentation.
Thank you. Welcome back to the community, Paul. It has been a minute.
Good evening, sir.
Good evening, sir.
Yeah, I'm Femi by name. What I want to ask is, where can can you just drop the software on the group? I mean, Revit 2025. I don't know if you actually did the tutorial about how to install it because I came to this thing late. So my question is just that, can you please just drop the software in the Telegram group so that we can install it, and the installation guide, I mean the activation.
Who is that again? Please come up again.
Yeah, I'm Femi. My name is Femi.
Yeah. Yes.
Okay, you need the question again.
No, I just wanted to get your name. So I wanted to ask, have you registered for the our cohort course? Sorry, have you
No,
registered
sir.
for it? Yeah.
No, sir. No, sir.
So the thing is, the softwares we get from Autodesk, they are limited in number. So we are not in a position to provide the software for everyone. We only have a limited number of licenses that we can provide.
All right. Thank you, sir.
Okay. Sorry for any inconvenience caused.
Yes, the
No
last
problem.
question.
Hello, Lutaya.
Yes, Engineer Gatim, I wanted to ask, do we need really do we need to model the roof when we are, because as in, do we need it during the structural analysis thing, or it is not necessary to model the roof, because I'm seeing it also remains in the architectural bit of it. Like,
Yeah.
can it also be exported with, at the time of exporting to a finite analysis software?
That's a good question, Latoya. I honestly do not export the roofs for design. I only calculate the loads from the roof manually and then apply them to my lintel beams for design. So if what you want to do is to export your model to a finite element or to another software for design, you do not need to model your roof. But if you want to detail your roof details, such as the trusses, the purlins, etc., I recommend you modeling the roof first so that it acts as a guide as you model those particular elements. Lutaya?
Yes, I'm getting.
Yeah, super. So I end this meeting at this point. If you have any other questions, please raise them in the WhatsApp channel. If you are ready to join any of our WhatsApp channels, I think let me drop the link in the chat box. I hope I have it. Okay, so I have shared the link to our WhatsApp channel. Get to move around the communities. I think this is the link to the Civil 3D course. We also have Revit for Structures WhatsApp channel. Just move around the community, see what groups work for you, and join them. So thank you for attending today's session. I am looking forward to seeing you tomorrow and also on Friday. So good night and have a lovely holiday tomorrow.
Good night. Thank you.
Thank you, sir. Good night.
Thank you, sir.
Muchly appreciated. Thank you very much.